All right, guys, this is for those of you who have not been able to be at school or need a quick review. I am not going to be doing the you try because I have already posted the answers for this on It's Learning. So let's go over these examples. Notice at the top of the page, you have all of your formulas for sine, cosine, tangent. And notice the difference. This was a biggie that when this is a plus for cosine, this is a minus in the formula. And tangent plus yields not tangent, sine plus yields a plus in the formula. So these two are totally different. And then you just got to pay attention to these signs. What do they come out over here? I have ways that I remember them because I have to have them memorized, or I had to for college. So when I memorized them, I had ways to help me remember them. And you may have to have them memorized someday, just not for me. All right, so let's start with this sine of 135 plus 60. Now, um, any of these that you're going to need the unit circles. So just for convenience, I'm going to draw a partial unit circle. And this one is out 1, up 0. I've got a 45, I got a 30, and I got a 60. Wow, that's not quite right, but okay. So this is 30, 45, 60, 90, and of course, sine or cosine and sine are the order of the parentheses. So this one is square root 3 over 2 and 1/2. Square root 2, square root 2 over 2. Excuse me. That should not have been a square root. Let me grab this real quick and get rid of that little square root sign. Got rid of more than I needed. Go back. There we go. And then this one is 1/2 square root 3 over 2. And out 0, up 1. And the final thing that I'm going to do to this is go back and add in the tangent. I'm just going to put tangent in green. Tangent for this one is 0. It's square root 3 over 3. It's 1. It's the square root of 3, and it's undefined. Okay, and I'm going to show you why I like that. And if you need this, this is pi over 6. This one's pi over 4. This one's pi over 3. And this is pi over 2. Okay, with that done, let's go into this. So we have 135 plus 60. 135 is over in the second quadrant, so it's going up this way, and it's the same as the 45. And then 60. So first of all, just filling this in, I have sine of 135 plus cosine, 60, and then plus cosine of 60. Oh my gosh, I am really tired, guys. I maybe shouldn't be doing this late at night. Yeah, it's 8:45, and I'm just tired after a long day at school. Okay, cosine 135, sine of 60. So the way that you do this is you take the 135, which is the square root of 2 over 2, and cosine is square root of 2 over 2, except it's negative. Okay, I just filled these in using this information, but knowing that it's in this quadrant. Okay, and then I'm going to take purple I'm going to fill in cosine of 60 and sine of 60. That's right here. All right, so that's going to give me cosine of 60 is 1/2 plus sine of 60 square root of 3/2. So if I simplify these, you multiply the top, you multiply the bottom, you get the square root of 2/4, and over here you get negative square root of 6/4, and that is a grand total of 2 minus the root of 6 all over 4. Now, you may want to reduce this. You cannot. That is not okay. There is, oh, and I left the square root out. There is nothing that will combine from the 4 being a rational number with the irrational numbers. They're just not reducible. They're not. You're done. Final answer. All right, so cosine is going to be, this one follows a different rule. You're using the second one, okay? And it's a minus, so it's actually the one that's over here. All right, so cosine 225 times cosine of 120, and this time it's going to be plus sine 225 sine 120. Now what you will want to do is take out your unit circles so you have those to use. All right, I'm going to go in and put in the sine and cosine of 225. That is negative square root of 2/2, negative square root of 2/2. Then I'm going to go back in and I'm going to put the cosine and sine of 120. Well, 120 and 60 are the same bird. It's just over here in this quadrant. So if it's in this quadrant, and I am going to need to erase all of this stuff. If it's in this quadrant, all right, then it's going to match up to the 60, and you're welcome to use that. So I have 1/2, and I have square root of 3/2. Now, since I'm in quadrant 2, I'm going to think back about this and know that the cosine's negative, the sine is positive. So I still have this, and I'm going to add, wow, I think I can call this the Christmas problem. Look at that red and green. All right, so I'm going to multiply the beginning, and that's going to give me square root of 2. I'm going to multiply the ending, and that gives me negative root 6. And it's all over. 2 times 2 is 4. Both sides would give you the same thing. We're done. Next thing I'm going to do, and please feel free to do the A and the B over here under the U try. I've got all of these answers posted on It's Learning. So the next thing that I'm going to is the sine of 75. Now this one's different than these two because this one represents the sine of 195. This one represents the cosine of 105. I had to look and see what it would be. Had to do that math. I did it kind of quick. Hope it's right. Sine of 75 is I want to think about what's on the unit circle, what degrees are there that I could use, excuse me, to get 75 degrees. So on this one, what I did is I said this is the same as sine of 30 degrees plus 45 degrees. Is it okay if I switched around and say 45 plus 30? Absolutely, because order of addition does not matter. So once I get this set up, I'm going to go ahead and say sine of 30 cosine 45 plus cosine 30 sine 45. I will use substitution and get the final answer. So substituting in for 30, I'm going to get square root of 3/2 and 1/2. And cosine of 45 is square root of 2/2. Sine is square root of 2/2. final answer, square root 6 plus square root 2 all over 4. The end. You don't have to add each time. You can subtract if need be. So in this one, and you've got your paper, I am not going to keep all of these formulas sitting out in front of me. I can't do it, don't have the room. So cosine of 15, you could use 40 minus 30, 45 minus 30. So replacing this 15 with 45 minus 30, that would give me 15. So now I can find that angle measure. Okay, so take your 45 minus 15, cosine of 45, cosine of 30. This is going to be a plus because the sign changes. Sine of 45, sine of 30. Go ahead, replace all of these and get your answer. I'm just going to keep setting them up, except when we get to tangent, because tangent's a little bit different. With tangent, I am going to tell you, I really need my tangents. I need to know what they are. I'm just going to redraw it right here. This tangent is equal to 0. This tangent is at the 45 and tangent equals 1. This tangent of 30 is square root of 3 over 3. And you can always put it in your calculator to double check me on this because you never can trust Miss Butel when she's tired. And she's very tired tonight. Okay, feeling a little Bob Rossi there, And this little tangent lives over here. This tangent is undefined. Okay, so we've got those drawn in. Now, because this tangent, and I'm going to circle it in red, because the tangent of 30 and any of them with the same reference angle of 30 make this true as well. Because it's the square root of 3 over 3, it makes these problems really nasty. So I want to avoid using 30 degrees if possible. All right. So if I take, 60 plus 45, I just avoided using a 30 degrees there. I don't want to use 135 minus 30 because 30 degrees is really mean. It's not nice. Trust me on it. If you don't, use 30. See if you have fun with that. Enjoy it. All right, so what I'm going to do, you need to look back at the top of your paper, but the tangent is 1, not 1 plus. This one's actually tangent, excuse me. Tangent of 60 plus tangent of 45 all over, and let me clean that up. It bothers me. Okay. 1 minus tangent 60 times tangent 45. Now, what I'm going to do is just replace all of these values. I can tell you that tangent of 60 is the square root of 3. I can tell you that the tangent of 45 is 1. So this one's square root of 3, this one's 1. So what this looks like is the square root of 3 plus 1 over, now this is going to be 1 minus square root of 3 times 1. You have to do square root of 3 times 1 first because order of operations makes us multiply for adding. Then add. Okay, that's order of operations from the 6th grade. So what I have right now is the majority of your points. When I'm doing this one on a test or something like that, that is the majority of the points, but it's not done. To finish this problem, I have to multiply by the conjugate of the denominator. The conjugate of the denominator will be everything exactly like it is, but we change the back half from positive to negative or negative to positive. And then the numerator has to be done in the same manner. All right, so when you do this, you are welcome to use a box. Wow, am I ever pushed for room on these boxes? A box that says 1 plus the square root of 3 and square root of 3 plus 1. This is the numerator, okay? So this leaves me square root of 3, 1, 3, square root of 3. Now, I did this today in class. I mentioned this with the kids because it's really easy for kids to look at these two and say, oh, 3 plus 1 is 4. But then they look at the square root of 3 and square root of 3 and don't know what to do with it. And I asked them today, what is x plus x? And lo and behold, somebody told me it was 2x. And I said, are you sure? And they thought a minute and said, yes. And I said, I would agree with you. So if x plus x is 2x, then the square root of 3 plus the square root of 3 right there has to equal 2 times the root of 3. In the same way that x plus x is 2x. All right, so what I have to do in here is add 2 plus the root of 3. Now, this bottom number is a little bit easier. You're welcome to take that one and multiply it out. I'm going to tell you what happens with this every time. Use a box like this. Take your time, do it. Stop the video, get an answer. I'm going to tell you that what happens on this guy is that you get 1 times 1, which is 1. And because it's a conjugate, you get square root of 3 times square root of 3, and don't forget the sign. So it's minus 3. Now, when you simplify this, this gives you 4 plus, this is an equal, that's not a negative, 2 root 3 all over negative 2. Well, then I have to reduce that. I've got to simplify that as much as I can. I am going to do V cancellation, and I'm going to divide every part of this by negative 2. 4 divided by negative 2 is negative 2. Positive 2 divided by negative 2 is negative 1 times the root of 3. There is negative 1 times the root of 3, and my final answer. Okay, this problem right here on C is another example that you can try for number 5. All right, moving on down to number 6 and 7. And then I'm going to stop. I'm going to separate this in the same way I did it in class. This one's actually pretty easy. You look at the pattern, sine, cosine, cosine, sine, and you say, does this represent sine or cosine? Well, somebody in class said, well, it starts with sine, so it's a sine. And you know what? They're right. I got to give it to them. And I want to say it was somebody in my 4th period. Go 4th period. All right, so sine of 50 and 10. Then you have to say, if it's sine, do I follow this symbol or does it change? Well, sine follows it. So this is going to be sine of 60. And the sine of 60 is square root of 3 over 3. Excuse me, over 2. And I'm done. This one is cosine, cosine, sine, sine. That's following the cosine fashion. And I have a 120 and a 15. And the question is, do I add or subtract? Well, this is subtraction, so this goes to addition. So this is cosine of 315, which means it's one of those 45. So it is a square root of 2 over 2. It's in the 4th quadrant, so it stays positive. I'm done. I am going to take on 8 and 9 in a separate video, so I'm going to stop for right now and let you have this video for you.